Okay, so what we'll graph first, this is on the top of page 18, is our secant. And the first thing that we're going to graph is f of x is equal to the cosine of x. And the reason why we're going to graph that is because these two are reciprocals. So here you just have standard axes. Sometimes you'll have to draw your own. Sometimes you won't have a y-axis so that you can adjust it for yourself. So what we want to do is go from 0 to 2 pi, put pi here, we've got pi over 2, and remember we're just going around the unit circle, so this is 3 pi over 2. And remember we're graphing the cosine first, so we have an a value for cosine of 1. So we're going to very lightly, and I'll use a highlighter for this, we're going to graph our cosine. So I'll lightly put a point here, here, down here, just very lightly, because I only need this as a guide. So I'm going to use a dotted line and just graph it like this so that we can see it. Okay, so there's my cosine graph. And what I need to look for first is where does the cosine cross the baseline. So here at 3 pi over 2, I will have a vertical asymptote, and at pi over 2, I will have a vertical asymptote. So you have vertical asymptotes at pi over 2 and 3 pi over 2. Now remember, this is for the parent function. Okay? So then, these are for our 5 key points. At the point 0, remember this is for the secant, I have a value of 1. Because what's going to happen is you're taking this portion of this graph and you're going to flip it up, and it's going to go up in this direction towards the asymptote and away from the x-axis. So that means I have a point at 1, and then at pi I will have a point down here at -1, and 2 pi I will have a point at 1. So there's my table, because this is now what I need to do. So as I stated before, I'm going to take this portion, this orange portion of my graph, and I'm going to flip it upward and head towards the asymptote and up towards positive infinity. Do the same thing on this side. So these are the two small portions of the graph that are basically cut in half because of the asymptotes and the period. And then we're taking this parabolic or U-shaped portion of the graph and flipping it upside down. So this is like my pivot point. So I'm going to go down this way and down this way. So there is my secant graph. So again, we think of this as our max. We have where our intercept is. This is our min. Whoops, I forgot my vertical asymptote. So this is the intercept, and this is my max for my cosine. So when we talk about our range, remember we're coming from -infinity up to -1, and -1 is included. We jump over this orange portion. This really doesn't exist. We used it to help us get our secant graph, and then we're going from 1 to infinity. The period of this function is still 2 pi divided by b, which in this case is going to be 2 pi because my b value is 1. Vertical asymptotes in this case, we would write them as x equals pi over 2 and 3 pi over 2. There is a very general way to write it, but in this case, it's wherever my cosine crossed the baseline. This is for the parent function. It will not always be these two values. And then my domain, which is very, very general here, would be all real numbers, where x is not equal to, in this case, pi over 2 and 3 pi over 2, but you could have a general form of that as well. Let's move over to our cosecant graph. So for the cosecant graph, what we want to do is graph the sine of x first. Okay, so again we'll go from 0 to 2 pi. We've got pi in the middle, pi over 2 here, and 3 pi over 2 here. For the sine, we have an amplitude or an a value of 1. So we will sketch very lightly our sine curve, just so that I can use it as my guide. And if you notice here, my sine curve hits the baseline 3 times. So that means from 0 to 2 pi, I have 3 vertical asymptotes. 1, 2, 3. So even though you can't see it here, we know that we have a vertical asymptote here, we have a vertical asymptote here, and here. Okay, so we have a vertical asymptote, vertical asymptote, vertical asymptote. Okay, so for our sine curve, this would normally be an intercept, max, intercept, min, intercept. So wherever I have an intercept for my sine curve, I have a vertical asymptote for the cosecant. Where I have a max, that is going to be my maximum value, basically where this portion of my graph will flip up. So this at pi over 2 will be 1, and at 3 pi over 2 will be at -1. So to me, cosecant's a little bit easier because basically I take this parabolic shape and flip it upside down, like this, and like this, and this one I flip right side up and head towards your asymptotes but do not cross. So this here is my cosecant graph. Again, if you take a look at your domain, you could say that this is all real numbers where x is not equal to 0, pi, and 2 pi, but it's all variations of pi. So in this case, I'm just going to say all real numbers where x is not equal to 0, pi, and 2 pi. My range is the same as the parent function for the secant, but when you look here, you're coming from -infinity, and the graph stops at -1. We jump over what we did is our green portion, which is the sine graph, just we use that to graph the cosecant, and then we pick up at 1 and go to infinity. So my range goes from -infinity to -1, and then from 1 to infinity, and remember that will change depending on your graph. The period is still found by taking 2 pi divided by the absolute value of b, where in this case is 2 pi, and then here my vertical asymptotes are where x is equal to 0, pi, and 2 pi. For a vertical asymptote, you must write x equals.